Okay, so let's do in class number 3, question 2. A baseball hit 3 feet above the ground leaves the bat at an angle of 45 degrees and is caught by an outfielder 3 feet above the ground at a point 300 feet from home plate. So question, what is the initial speed of the ball and how high does it rise? Okay, so let me write our formula for finding the position that we proved in theorem 6. Okay, so here's the formula we'll be using. Where again, this is the v0 is the initial speed at time 0, so the magnitude would be the speed at time 0, theta would be the angle, t would be the time, h would be the initial height, g is gravity. Since we're in feet here, the gravity would be 32 feet per second squared. So let's write down what we're given now. Okay, so here's what's given. We're given the height. So the ball is hit 3 feet above the ground. That means that's h is 3. The angle is 45 degrees, so theta is 45. And it says also is caught by outfielder 3 feet above the ground. I'll come back to that. At a point 300 feet away from home plate. So it means the 300 feet would be the x direction, so the I component. So this I component must equal 300. I'm denoting that by r of t0 dotted with I. That would pick up the I component. That needs to be 300. And r t0 dotted with j, that'd be the j component, would be 3 because it's caught 3 feet above the ground. So in this picture over here, so it's, say, hit over here, and then it's going to travel and be caught over here at 3 feet. So it's the y direction right there. So r of t0 dotted with j would be 3, where t0 is the time when ball is caught. So it's the time it takes to go across here. So at that time the y value should be 3 and the x value should be 300. That's how I got these two equations here. Okay, so let's keep going now. I'm going to erase this picture now. Okay, so now r t0 dotted with I equals 300, so pretty much the I component has to be 300. So plugging in, so the angle is 45 degrees, the speed, initial speed is unknown, but we have this equation here, this is cosine 45. We can then solve for the initial t, we can solve for t0 here relative to this guy. So let's solve for t0. Okay, so solving for t0, so dividing by the speed and the cosine of 45 here. And the cosine of 45 is square root of 2 over 2. But you're dividing, so you do reciprocals, so it'll be 2 over square root of 2 times this stuff. So it's going to be 600 square root of 2 times initial speed. That's our t0. Okay, so now I'm going to erase some stuff up here and keep going. Summarizing, we have this so far. We find our t0 relative to our initial speed. Okay, we're going to use now that r t0 dotted with j is 3. So this j component needs to equal 3 with the h being 3, theta being 45, and the t0 being 600 over square root of 2's initial speed. So let's make those substitutions up here. And g being 32. Okay, let's do that. Okay, so setting our j component equal to 3 and using h being 3, angle being 45, then in place of t we're putting our t0, which is 600 over square root of 2 initial speed, minus then 1/2 g, g is 32, so it'll be minus 16, t squared will be t0 squared, so it'll be squaring this guy, so it'll be 6 over square root of 2 initial speed squared equals 3. Okay, so let's notice here the got 3 on this side and this side. They'll go away. And the sine of 45 is square root of 2 over 2. So let me make that substitution here. Okay, so now it becomes square root of 2 over 2 for the sine guy. So this will cancel. The initial speeds will cancel. Let's go into here, 300. We can then, let's move this guy over here then. Let's do that. Oh, we get this then. So now let's square these things in here and keep going. Get this then. So squaring 600, squaring the square root of 2 becomes 2, squaring initial speed squared. So it's become 8 here. And now let's cross multiply now. So cross multiplying, we get to here. Let's divide by 300 then. Okay, so dividing by 300 here. Then I'm writing 600 squared as 600 times 600. 300 goes into second order twice here. Then I'm multiplying a 2 with the 8 to make 16. So it'll be 16 times 600. Now let's take square root to find our initial speed. Okay, so taking square root, well, the square root of 16, and 600 can break up as 100 times 6. So we square root of 16 times square root of 100 times square root of 6. That's going to be 4 times 10, so 40 square root of 6. Plugging your calculator, you can check it's roughly 97.98 feet per second. Okay, so that's our initial velocity. All right, so we still have to find the max height. So let's make some observations here. I'm going to erase this stuff right now. So okay, so I've drawn our picture again of our baseball being thrown, or being hit, sorry. So the max height will occur here, and note that's going to be a maximum of the function, and the max occurs when the derivative is 0. So it's going to be derivative in the j direction being 0 we need to find. Okay, so let's take the j direction guy and take derivative and set it equal to 0. Okay, so taking derivative of the j component with respect to t, so derivative of h would be 0. Derivative of t would be just 1, so it's going to be speed times sine of the angle, and derivative of t squared would be 2t. The 2 would cancel with the half and it would just become gt. In our case, the angle is 45, the g is 32, and our speed is 40 square root of 6, or you can use the 97.98. I'm going to use the 40 square root of 6. It's more accurate here. So let's make those substitutions over here. Okay, so making a substitution, 40 square root of 6 for the initial speed. Angle is 45 degrees. Sine of 45 is square root of 2 over 2. 2's cancelled here and becomes 20 here, square root of 6. G is 32 up here. Okay, then solving for 32t first, so moving this over here, multiplying both sides by -1, we get this. Then solving for t, we get, okay, so solving for t, you get 20 square root of 12 over 32, reduces to 5 square root of 12 over 8, which you can check is roughly 2.17 seconds. So at 2.17 seconds, it would be at its max height. Okay, so let's now find the max height. Okay, so the max height then would be r of 2.17 in the j direction. So the j component at 2.17 seconds. So plugging into j component, let's do that. Okay, so plugging into the j component, so here's the j component down here. So the h was 3 in our case, the magnitude of v0 is 40 square root of 6, angle is 45 degrees, the time was 2.17, then minus g was 32, so 1/2 of g, 16 times 2.7 squared. So plugging this into your calculator, you can check it's roughly equal to 78 feet. Okay, so therefore we found the max height. So we found the max height right here. So we've answered the question then, because we already found the initial speed. Just let me point it out again. Yeah, so our initial speed we found already was 97.98 feet per second, and we found our max height was 78. Okay, so we're done with the question. Alright, so let's leave it there.